All right, let's dive right into this explainer and crack the case of how we can figure out the exact price of unlabeled items at a market, using a kind of magic tool of mathematics. Welcome, everyone. Now, today we're tackling something that honestly sounds incredibly formal when you say it out loud, but it's actually this amazing everyday superpower. It's called first-degree equations with one variable. I know, don't let that huge name intimidate you. If you've ever been out shopping and had to do a little mental gymnastics to figure out what you're actually paying for a specific item, well, you're already halfway to being a master math detective.
Think about it. As a math detective, when you're faced with a mystery at the fruit stall, you need a reliable method to uncover the truth, right? Imagine this scenario. You're at the local market. You hand over your cash for a bunch of items, and that includes a delicious-looking apple that just didn't have a price tag. You know your total bill, you know the price of all the other things you bought, but what exactly did that single apple cost? You can't just guess here, we need absolute precision. And that is exactly where our mathematical magic tool comes into play. It takes the guesswork completely out of the equation.
So here is our lesson map for today to build up those detective skills. Number 1, the mystery of X. Number 2, the balance scale principle. 3 steps to success. 4 avoiding common traps. And finally, number 5, real-world math puzzles.
Okay, section 1, the mystery of X, uncovering the unknown. Let's see how this builds our understanding of what we're actually looking for when we stare down one of these math problems. So, the crucial point here is that this super intimidating mathematical term really just describes a tool we use to find one specific missing piece of information. A first-degree equation with one variable is honestly just a puzzle, where exactly one piece is missing, that's our one variable, and we usually just call it X. It's our prime suspect, it's our unlabeled apple, it's the unknown. And you know why it's called first degree? It's simply because our X is just plain old X. There are no squared or cubed powers to complicate our lives here. Just a straightforward mystery waiting to be solved. Moving right along to section 2, the balance scale principle, keeping it equal. Now, we absolutely need to understand the golden rule that governs our magic tool because this is the foundation of everything we'll do today. I want you to imagine a weighing scale where the equal sign is the center pivot. To keep it perfectly balanced, any action you take on the left side absolutely must be mirrored on the right side. And this brilliantly illustrates the absolute core of algebra. If you add 5 apples to the left side of the scale, you gotta add 5 apples to the right side. If you divide the left side by 2, well, you have to divide the right side by 2. If you don't do this, the whole thing just tips over and your case goes completely cold. But if you respect the balance scale, you will always find the true identity of X.
All right, section 3, 3 steps to success, your detective blueprint. Now that we understand the balance scale, let's look at the exact procedure we need to crack literally any of these cases. These 3 simple steps are your ultimate blueprint for success. But listen closely. Step number 2 is where you've got to be incredibly careful. Step 1 is to expand the brackets to get all your numbers out in the open. Step 2 is to group your suspects. You move all the X variables to one side of the equal sign and all your regular numbers to the other. But remember our balance rule. When you move a piece across that equal sign, you must change its sign. Finally, step 3 is just calculating the final value. Let's put this blueprint into action. This perfectly illustrates the exact flow of those steps in real time. Let's walk through this one together. Our mystery is 2x minus 3 times the quantity x plus 3 equals 2x. Okay, step 1, we expand. We multiply that minus 3 into the bracket. Minus 3 times x is minus 3x, and minus 3 times a positive 3 is minus 9. So our left side simplifies to minus x minus 9. Now look at step 2. This is the crucial move. We want our variables on the left and our numbers on the right. We move the 2x from the right to the left, and boom, it becomes a minus 2x. We move the minus 9 from the left to the right, and it becomes a positive 9. This leaves us with minus 3x equals 9. Finally, step 3, we isolate x by dividing 9 by minus 3. The result? X equals minus 3. Case closed.
Now check out this next one from our source documents. What's really interesting here is how the double negatives during our expansion step instantly turn into a positive 8, which leads us straight to the correct answer. The mystery is 2x minus 2 times the quantity 3x minus 4 equals 0. Step 1, expand. Minus 2 times 3x is minus 6x. But wait, look closely at the next part. Minus 2 times minus 4. 2 negatives make a positive, right? So that becomes plus 8. We simplify to get minus 4x plus 8 equals 0. For step 2, we move that positive 8 across the equal sign, so it flips to a minus 8, leaving us with minus 4x equals minus 8. Step 3, we divide -8 by -4. The negatives cancel out perfectly, and x equals 2. Another mystery successfully solved using our trusted blueprint.
Which brings us to Section 4, Avoiding Common Traps, Danger Zones. Let's talk about this, because honestly, even the best math detectives can fall into these traps if they aren't paying close attention.
Trap number 1. When expanding a number with a minus sign in front of the bracket, people frequently forget to change the sign of the inside number, and that will completely ruin your balance scale. Look at the left side here. The wrong way, -3 times the quantity x plus 3 becomes -3x plus 9. That is a massive trap. They multiply the 3, sure, but they completely forgot to carry the minus sign over to the second number. The right side shows the correct way, -3x minus 9. You've got to always carry that negative sign all the way through the bracket. If you miss this, your entire investigation goes completely off the rails right at step 1.
And here is trap number 2. Always flip the sign when crossing the equals boundary, positive to negative or negative to positive. If you move a number or a variable to the other side of the equation without flipping its sign, your scale tips right over and the case remains totally unsolved. Think of the equal sign as a kind of magic portal. Your numbers literally cannot walk through it without their outfit changing from a plus to a minus or a minus to a plus.
Okay, Section 5, Real-World Math Puzzles. Put it into practice. We've trained hard, we know the rules, and we know exactly where the traps are. So let's apply these newly sharpened skills.
These 3 scenarios are perfect proof that everyday puzzles, from buying snacks to guessing ages, can be perfectly translated right into first-degree equations. Let's look at Marie's pens. She bought 4 unlabeled pens and a book for 2,000 reals, spending 6,000 reals in total. The unknown, Rx, is the price of just one single pen. So 4x plus 2,000 equals 6,000. You just apply our 3 steps to find x. Now let's shift gears to sibling ages. The older brother is 5 years older than the younger, and their ages sum up to 25. If the younger sibling is x, the older is x plus 5. So x plus 5 equals 25. Finally, let's look at the bread run. You go to the store with 10,000 reals, you buy 2 breads, and you have 2,000 reals left over. The 2 breads, which is 2x, plus the 2,000 left over equals your starting 10,000. So 2x plus 2,000 equals 10,000.
You see, math really isn't hard when you know the rules. So I challenge you, use your 3 steps and your balance scale logic to solve these problems. Take these 3 real-world equations, be incredibly mindful of those danger zones, respect the balance scale, and find the true value of x. Drop your answers in the comments below. You are now officially equipped to go out there and solve the unlabeled mysteries of the world. Thanks so much for joining me on this explainer. Keep those detective skills sharp and ask yourself this: if a simple x can solve the price of your groceries, what other hidden codes in the universe are just waiting for you to balance the scale?